In this video, we are going to look at some examples of solving upper level polynomials and determining whether or not a value is a zero of an upper level polynomial. So in this first example, we are asked to use substitution to determine if -2 is a zero of the following function. So you would do this or approach this in the exact same way that you would approach any function. So here what we're essentially doing is we're looking at g of -2, which means anywhere we have an x, we're going to replace it with the -2. So this becomes -2 to the fourth minus -2 cubed minus 3 times -2 squared plus 5 times a -2 minus 2. In this case, all you do is you just simply reduce that down. Now, what we're looking for is if all of this reduces to 0. If we end up coming out with an answer of 0, then we would claim that yes, -2 would be a 0. However, if when we plug -2 in we get something else, then it would not be a 0. So by reducing everything down or evaluating, you could go ahead and use a calculator to do so. What you're going to actually come out with is that g of -2 equals 0. So please take a moment to verify this by going ahead and working the problems out. Remember order of operations. Okay, so for example, -2 to the fourth power, the fourth is even, which means the negative goes away. You would have 2 to the fourth. However, with the odd, the negative stays. Negative and a negative is positive, and so on and so forth. In this case, because you get it to equal 0, you still have to answer your question. So the answer would be that yes, -2 is a 0. Now let's look at one that's a little bit more advanced. Here again, we want to determine if the given value of x is a 0 of the equation. In other words, we're looking to see if it solves. So in this case, I have x squared plus 13 equals 4x. So there's a couple things that I can do. One of the easiest things to do is to start with your equation. So here I have x squared plus 13 equals 4x. And I could simply plug x into the equation here. So this would do 2 plus 3i plus 13 is equal to 4 times the 2 plus 3i. And then when I solve these down, what I'm looking for is that we get the exact same thing on either side of the equal sign. So the first thing I would do here is square this. So here we would end up with 4 plus 12i plus 9i squared plus 13 is equal to, distribute on the other side, 8 plus 12i. And now we've got some terms to combine. So first I have the 4 and the 13. So this is going to give me 12i. I'm going to have plus 9 times the -1. And that's because, remember, I squared is -1. And then I have plus 17 is equal to 8 plus 12i. When we combine this piece here, we end up with 12i plus 8 is equal to 8 plus 12i. Therefore, yes, 2 plus 3i is a 0. Alright, so here we have that we need to find the zeros of the polynomial functions and state the multiplicity of each. So we're looking for the zeros, but then we're also looking for multiplicities. So remember, multiplicity is the number of times that the 0 occurs. So the first thing that we want to do is we need to find the zeros. So we have each part that can be broken down. So the first thing we have is we have -8x to the fourth is equal to 0. We then have the middle part, x minus 3 squared is equal to 0. And we have x plus 4 cubed is equal to 0. Now there's a few things we need to look at. First and foremost, this value here and this value here are my multiplicities, along with this one here. So these are the multiplicities. So we're looking at this one, we're looking at this one, and we're looking over here at this one. Okay, so it's the number of times that your function is occurring. So that being said, what we do here is we solve for x. So here we're going to end up with x being 0. Over here we're going to end up with x being 3. And here we have x equals negative 4. So what we're talking about is we are talking about having your zeros of being 0, 3, and negative 4. And then we have to look at the multiplicities. So here, if we look at your multiplicity, we have that 0 gives you a multiplicity of 4. 3 gives you a multiplicity of 2. And negative 4 gives you a multiplicity of 3. Meaning they are going to occur that many times. So 0 here occurs 4 times, 3 occurs twice, and negative 4 occurred 3 times. Now notice in this problem we're not looking for you to expand the function out or anything like that. We're just looking for these pieces of information. Alright, let's look at another one. So here I have x cubed minus x squared minus 2x plus 2. So it's not quite as easy to figure out what the multiplicities might be. So instead what we have to do is we need to factor this down to its pieces. I have 4 terms here, so the first thing I would do is I would do grouping. So I would look at the first term first, and here what's in common is the x squared, so I would pull out the x squared, and what's left behind is going to be x minus 1. The next thing that I need to look at is the second piece, and so here the x squared times x minus 1 comes through. And what's in common between both of these is going to be the negative 2, leaves behind x minus 1. So what we actually have here is we have that f of x is going to be x squared minus 2 times x minus 1. Now, once we do that, notice each of these factors has a 1. So what this means right here is that all of them have a multiplicity of 1. So we have x squared minus 2 equals 0, and we have x minus 1 equals 0. So the easy one says we know that x equals 1. Here we've got that x squared equals 2, so x equals plus or minus the square root of 2. Once we do that, now we have everything we need. So in terms of my zeros, we have plus or minus the square root of 2, and we have a 1. And then in terms of your multiplicity, we have that all zeros have a multiplicity of 1. And that's just because the factors did not have any powers. Alright, let's look at another one. Here I have x squared minus 2x plus 5. So in looking at this one, notice it's not really very easily factorable. So instead what we would do is we would use the quadratic formula. For those of you who need a refresher, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, what we would do is we would plug in. So this would be negative of the negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 all over 2 times 1. When we reduce that, we're going to end up with 1 plus or minus 2i. So in this case, we would have that my zeros are going to be 1 plus 2i and 1 minus 2i. And then in terms of your multiplicity, again, we would have that all zeros have a multiplicity of 1. Now, if there's any confusion about applying the quadratic formula here, my best advice would be to go back and refresh yourself with using some quadratic example formulas in order to pull those out of algebra. Alright, let's look at one last one. So here I have x to the 4th plus 7x squared is equal to 8. So the first thing I would do is set this equal to 0. So this becomes x to the 4th plus 7x squared minus 8 equals 0. And then here we have something that is easily factored. So this becomes x squared plus 8 and x squared minus 1 equals 0. So here we're going to end up with x squared plus 8 equals 0 and x squared minus 1 equals 0. Both of these have a multiplicity of 1 because the factors themselves don't have any powers. So here we get that x squared is equal to negative 8. So x is equal to plus or minus 2 square roots of 2i. On the other end, we get that x squared is equal to 1. So x is equal to plus or minus 1. So for this one, we have 4 zeros. We have plus or minus 2 square roots of 2i. And we have plus or minus 1. And then again, we have that all zeros have a multiplicity of 1. So there is a pretty good introduction on what it means to find zeros of upper level polynomials and the multiplicity that comes along with those zeros. So if you have any questions, please let me know. Otherwise, I hope you enjoyed yourself, and I'll see you next time.